So in this tutorial, we want to look at solving simultaneous equations when the one equation is a linear equation and the other one is a quadratic equation. So in question 1 here, we have to solve these two equations simultaneously. And as you can see, the one equation is a quadratic equation and the other one is a linear equation. The first thing to note here is that both equations are in the form y equals. So when this is the case, we simply make the right-hand sides of the equations equal. So we let x squared minus 9x plus 21 equal to 2x minus 3. We want to solve this equation, so we're going to bring all our terms to the left-hand side. So minus 2x plus 3, and this is equal to 0. Now we can add like terms. Negative 9x minus 2x is negative 11x. And 21 plus 3 is 24. So we end up with a new quadratic which we can solve. We can use any method. We can use factorization or the quadratic formula. I'm going to use factorization. So x minus 8 times x minus 3. So negative 8 times negative 3 is positive 24. And here we're going to get negative 8x minus 3x, which will give us negative 11x. So we can now use the zero product rule. So x minus 8 is 0, or x minus 3 equals 0. And solving for x, we get x equals 8, or x equals 3. So now that we have the x coordinate, we can find the corresponding y coordinates. And we can get the y coordinates by plugging these values for x back into any one of the two equations. Of course, it's going to be much easier to plug it into the linear equation. So into y equals 2x minus 3. So we can plug in x equals 8. So y equals 2x, so 2 times 8 minus 3. And this is 16 minus 3, which is 13. And here we plug in x equals 3. So 2 times 3 minus 3. So that's 6 minus 3, which is 3. So our coordinates here will be 8 for x and 13 for y. And here the coordinates will be 3 and 3. So in question 2 here, we have to solve these two equations simultaneously. And once again, we have a linear equation and a quadratic. You should note that in this case, the equations are not in the form y equals. So we cannot make the right-hand sides of the equations equal, like in question 1 of this tutorial. What we're going to do instead is to make either x or y the subject in any one of these two equations. However, we want to avoid fractions. So, for example, if we had to make y the subject in the first equation here, we'll end up with a fraction. If we make either x or y the subject in the second equation, we will also end up with a fraction. So what we're going to do instead is we're going to make x the subject of the formula in the first equation here. So x minus 3y equals 13 will give us x equals 13 plus 3y. Now we're going to substitute this into the second equation. So wherever we have an x, we're going to put in 13 plus 3y. So it's twice 13 plus 3y all squared minus 9y. And we're also going to bring the 116 here to the left-hand side. Now we can square out the brackets. So 13 squared is 169. Then we have a plus. 13 times 3y is 39y. Times 2 is 78y. And then plus 3y all squared will give us 9y squared. We can multiply the 2 here into the brackets, and we can use a calculator. So 2 times 169 is 338. Then 2 times 78 and that's 156. So 156y. And then 2 times 9y squared is 18y squared. Now we can add like terms. And we can also write this equation in standard quadratic form. So 18y squared. And adding the like terms. So we have 156y minus 9y, which is 147y. Then we also have 338 minus 116. And that's 222. We can use the quadratic formula now to solve this quadratic with. In this case, our variable is y, so we're going to write the quadratic formula in terms of y. So we have y equals negative b plus minus the square root of b squared minus 4 times a times c. And this is all over 2a. So with 2 times 18, so 36. We can use a calculator to work out what's under the square root here. And it comes to 5625. This is all over 36. So now we can write down the two answers for y. And this we can do on a calculator. So negative 147 plus the square root of 5625 divided by 36. And we see it comes to negative 2. Then we also have negative 147 minus the square root of 5625 divided by 36. And it comes to negative 6.17. So now that we have the values of y, we can plug it back into this equation into x equals 13 plus 3y to find the corresponding values for x. So x is 13 plus 3y. So here we have x is 13 plus 3 times negative 2, which is 7. And here we have x equals 13 plus 3 times negative 6.17. So it's 13 plus 3 times negative 6.17. And we get an answer of 5 or negative 5.51. Let's look at question 3 here. We have to solve these two simultaneous equations, one linear equation and one quadratic equation. Now, in this case, y is already the subject in the quadratic equation. So what we're going to do is we're going to substitute the quadratic equation into the linear equation. So where we have a y, we're going to put in x squared minus 18. So we have 4 times y. So 4 times x squared minus 18 plus 3x. And we can bring the 13 to the left-hand side. So this equals 0. We multiply out the brackets. Now we can add like terms. And we can also write the equation in standard quadratic form. So negative 72 minus 13 is negative 85. Now we end up with a new quadratic, which we can solve by using the quadratic formula. So x equals negative b plus minus the square root of b squared, which is 9. So 3 squared is 9, minus 4 times a times c. This is all over 2a. So 2 times 4, which is 8. We can use a calculator to work out what's under the square root here. So it's 9 minus 4 times 4 times negative 85. And it comes to 1369. This is all over 8. So now we can write down the two answers for x. So we have negative 3 plus the square root of 1369. All over 8, or negative 3 minus the square root of 1369 all over 8. Let's use the calculator. So negative 3 plus square root of 1369 divided by 8. And it's 4.25. And then we also have negative 3 minus the square root of 1369 divided by 8. And we get negative 5. Now that we have the x values, we can find the corresponding y values by plugging these x values back into this equation here, into y equals x squared minus 18. So y is x squared minus 18 so 4.25 squared minus 18, which is 0.0625. And here we can plug in the negative 5 into x squared minus 18. And this comes to 7. So negative 5 squared is 25 minus 18, which is 7. So when x is 4.25, y is 0.0625. And when x is negative 5, y equals 7. So in question 4 it says, the line y equals x plus 1 intersects the graph of y equals x squared minus 3x minus 11 at the points A and B. So at these 2 points, A and B, find the coordinates of A and the coordinates of B. What's important to note is that whenever we solve 2 equations simultaneously, we are really finding the coordinates of the points of intersection. In other words, we must solve these 2 equations simultaneously. Since both are in the form y equals, we can make them equal to each other. So x squared minus 3x minus 11 equals x plus 1. We can bring all our terms to the left-hand side and add like terms. So negative 3x minus x will give us negative 4x. And negative 11 minus 1 is negative 12. Now we can factorize and solve this quadratic equation. So x minus 6 and x plus 2. So solving for x here, we find that x is equal to 6, or x is negative 2. Now we can find the corresponding y values by plugging these 2 points back in to the linear equation. So when x is 6, y will equal x plus 1, so 6 plus 1, which is 7. And when x is negative 2, y is going to be negative 2 plus 1, which is negative 1. So then the coordinates of the points of intersection will be 6 and 7, and negative 2 and negative 1. Now, when we look at the point A here, A is in the first quadrant, so both x and y will be positive, which means this point 6 and 7 will be the coordinates of point A. Here, both x and y are negative, and B is in the third quadrant. X is negative, y is negative. So this will be point B. So here's quite a challenging question on simultaneous equations. It says the curve y equals x squared minus 2x plus 1 is drawn on a curve. A line is drawn on the same grid. The points of intersection of the line and the curve are used to solve this equation with. Find the equation of the line in the form y equals mx plus c. So where do we start? Since both the equation of the curve and the line are in the form y equals, we're going to start by making them equal to each other. So we're going to let x squared minus 2x plus 1 equal mx plus c. We want to write this equation in standard quadratic form. In other words, we want to write it in the form ax squared plus bx plus c equals 0. So we can collect all our terms on the left-hand side and add like terms. So we have x squared minus 2x minus mx. So we write the terms in x next to each other, plus 1 minus c equals 0. This equation is not yet in this form. We need only one term in x, or we want only one term in x, but here we have 2 terms in x. So to deal with that, we're going to take out x as a common factor. So when we take out x from 2x, we're left with 2. Then we need a plus here, because a minus times a plus will give us a minus. And removing x from here, we're left with m. Now this equation is in standard quadratic form. We have one term in x squared, one term in x, and then the constant will be 1 minus c. Now the equation that we get here must equal this equation. In other words, x squared minus brackets 2 plus m times x plus 1 minus c must equal x squared minus 7x plus 5. And we need to find the values of m and c. So we can use inspection. In other words, we're going to compare the coefficients on the left-hand side with the coefficients on the right-hand side. On the left-hand side, we have 1x squared. On the right-hand side, we also have 1x squared. Then our term in x is negative brackets 2 plus mx on the left-hand side. And on the right-hand side, it's negative 7. The coefficients on the left-hand side must equal the coefficients on the right-hand side. So that means 2 plus m must equal 7. And we can solve for m here, and m is going to be 5. So 7 minus 2, which is 5. The constant on the left-hand side is 1 minus c, and on the right-hand side it's 5. So that means 1 minus c must equal 5. So we can solve for c. Negative c will equal 4. So 5 minus 1 is 4. And in dividing by negative 1, c will equal negative 4. So the equation of the line then will be y equals mx. So y equals 5x plus c, and c is negative 4. So 5x minus 4.